So, Kevin, what would you like to talk about today?
I think I'd like to talk about titration today. There are some sections of it in the book. One of the first labs of this course is a titration, so even if most of this course is online, it's a good in-person lab procedure to know and to understand. So I think that'd be a good topic for today.
When we decided what labs to put in this course, we looked at all the ones we typically do, and we said, these are the ones that have the most important chemistry techniques that we want students to learn, because we don't know how the semester is going to go. And so this first lab, it's probably the one that we want people to do the most, right? It's that doing one that's a titration is really important. So in the lab manual, it describes titrations. In Cengage's text, it talks about titrations. I'm going to describe for you the way that I finally understood what was going on with titrations, and maybe it'll resonate with you and with our students as well. So with titrations, they're a technique that we use to use one chemical to find out how much of another chemical you have. So you have two things reacting together, and often we do acids and base titrations, but there are redox titrations, there are different types of titrations. But in general, a titration is a way for you to use one compound to find out how much of another compound you might have. And you have a reaction, and as the reaction proceeds, you've got, we'll call it compound A, and maybe this is the compound that you know a lot about. So you know a lot about compound A, and you're going to react it with compound B, and compound B is, there's something unknown about it. Typically, it's the concentration that you don't know, and so you're going to use this compound that you know a lot about to find out about this other compound. And they might react, and they might join together, or it doesn't really matter what the product is in this case. We're just going to use this compound to tell us something about the one that we don't know about. And so I'm going to pretend that I've got this container, and in this case, it's going to be a beaker, and it's full of bees. Okay, it's got 5 of them, but we don't know that because we don't know how it concentrated, but it's got some bees in there. And I'm going to put inside that, I'm going to drop in an A. And when I drop that first A in there, oh, this reaction can take place. And so I'm going to form an AB. So that's 1. I'm going to drop in a second one, another A. I'll circle those to hold those together. In fact, maybe I'll circle it up here. Okay. So right now, I know that I put in 2 A's, but I don't know. I don't know how many B's there are. In fact, maybe I'll hide these ones, right? Now you and I both know that there's 5 in there, but I don't know because some of them are hidden by my finger. So I'm going to throw in another A. And have I used up all the B's?
Do I say I don't know?
I don't know, right? Well, yeah, we know we haven't. So I'm going to throw in another one. And I'm going to throw in another one. Oh, I did forget to circle that one. And I'm going to throw in another one. Now, I've just got this 1A floating around in there. So because we knew that we had 5 B's, it's a big secret, but we didn't really know that. As I start adding A's in there, they start to react and they form the product AB. But here is this A hanging around. And so now I can just keep on adding A's and I won't get any more product for it. If I had a way of knowing when this A was available, when this extra A had been added, I want to know 1, 2, 3, 4, 5. I want to know as soon as I put these 5 in there so that I know that I must have, so I find out that I had 5 B's. And so in a titration, we're going to use a compound that we know a lot about to find out something about an unknown, but we need something to tell us when do I have extra A's. And so I need some way of knowing that. And the way that we do that is we stick another compound in there that will only react with A after all the B's are gone. So I'm going to put compound C in the container. And I put compound C in because C will only react with A once all the B's are gone. And it just so happens that compound C changes color when we make AC.
Mm-hmm.
So we're going to go through this all again, but this time I want you to remember, we're going to see a different, we're going to be able to notice a different color when the compound AC forms. Okay?
Okay.
So here is A reacting with B to form AB. Okay? And here's my beaker. And this time, you can see it's got some B's and I've got some C in there as well. But you don't know how many B's I put in there, do you, Kevin? Because I hid it. Right? So I'm going to keep that hidden. And so I'm going to take an A and I'm going to put it in there. There's a B. So it's going to react. AB. There's another A go in. Oh, you can see that there's at least another one coming because I'm drawing it in there. There's another AB. So has my compound C reacted yet?
No, not yet. I don't think so.
No, exactly. My color hasn't changed. So now I'm going to put a third A in there. There's a third A. I'm going to put a fourth A in there. There's another B. So I know, so far, I know I put in 4 A's, so I know I've got 4 B's because I've not seen my new color react. Oh, there's a C. I guess I don't know that C's in there yet. Oh, there's a C. That's not good. There's another B. So I'm going to put in another A. I'm going to put in another A. And now so far I put in 1, 2, 3, 4, 5, 6 of my A's. I've reacted 6 of my B's. The next A that I put in is going to react with a C, and I'm going to get a color change. As soon as my AC forms, I get a color change. And so I know, oh, if I put in 7, I get the color change. 6 must have been how many B's that I had present. How am I doing?
Yeah, I think that makes sense. It's just like when you run out of ingredients or you don't know how many ingredients you have when you're cooking.
Yep.
And you want to make like multiple sandwiches, multiple cakes or something. Once you run out of one thing, then you know how much of that thing you had because you're all
Yeah.
out of it.
Yeah,
So I think
exactly.
that makes sense.
Yeah, exactly. So what we're now, this was with a generic A, B, and C. No, that's not really, those aren't real compounds, of course. So here is one that we're going to use and our students are going to use a lot. The compound is called phenolphthalein. And phenolphthalein is a weak acid. And what that really means is that phenolphthalein, we're going to call it pH for phenolphthalein, that sometimes it has a hydrogen attached to it. And if it has a hydrogen attached to it, it's colorless. But if I can take that hydrogen away and just have the phenolphthalein by itself, which I'm going to put a little minus sign there to remind myself because it's locked, it's pink. So phenolphthalein will change from colorless to pink if I can get rid of this hydrogen. And so I'm going to separate over here. My hydrogen, showing that it's separated from the phenolphthalein. So it's colorless when it has the hydrogen attached, and it's pink when the hydrogen is removed. Okay. So what we're going to do is we're going to put into this container a certain amount of acid. In this case, I'm going to put 3 acid molecules in there. And I'm going to put in some phenolphthalein. And so I've got 3 molecules in there, but maybe I've got 3,000. I don't really know exactly how many I've got there, but again, we know as a secret right now I've got 3 of them, but I don't know how many acid molecules I've got in there. And so I'm going to take a base like sodium hydroxide, and I'm going to put one of those in there. And so when I put my sodium hydroxide in, it's going to react with my acid. And I've still got a phenolphthalein here. It's still sitting in acid. And so the color is colorless, doesn't show up any color. I'm going to put another sodium hydroxide into there. And it's going to react with NaOH. Okay, still keeping the secret one. Let's set the secret one covered. So I put 2 sodium hydroxides in there. Oh, my phenolphthalein apparently is still sitting in acid, so it's still colorless. I put a sodium hydroxide in. It reacts with my acid. And right now my phenolphthalein still sitting just like it is. I've actually at this point used up all of the acid that I had present. I put in 3 of these sodium hydroxides. As soon as I put in my 4th sodium hydroxide, it will take this hydrogen off of the phenolphthalein. And now I have the phenolphthalein without the hydrogen. All of a sudden the color goes from being colorless to being pink. And so I know, oh, as soon as it turns pink, that was the point at which I had exactly the right amount of sodium hydroxide added in for the acid that was in the container already. And so by the titration is we use the compound that we know a lot about to find out something about a compound that we don't know quite so much about. And it uses these indicators. In this case, we've been talking about phenolphthalein, and it's an indicator that changes color from colorless to pink when we remove hydrogen from it, which we use that color change to tell us when to stop adding the sodium hydroxide. What do you think of that, Kevin?
Okay, yeah. So instead of with the A and B and C, we have like real compounds. We have a real like color indicator.
Yeah.
So it all works out, just like you said in those last two examples.
Yeah, yeah. So the point of a titration is really to use a compound that we know a lot about to find out about a compound that we don't know so much about it. And the thing that really made it easier for me when I began to really understand this was thinking about acid-base indicators are really weak acids and bases, and when the hydrogen is attached to the compound, it has one color or colorless, and when it's separate, when that hydrogen is removed, that's when the color changes. And so it's the first drop, the first few molecules that in which you see those color changes, that tells you that's the point at which you can then use a little mathematics to figure out how much is present in the unknown compound.
Yep, and that's basically titrations in a nutshell.
Yeah. Okay, thank you, Kevin.
Thank you, Dr. Hunter. Talk to you later.